All right, we're going to continue the discussion with the Pythagorean theorem. Of course, from Pythagorean theorem, we know that in any right triangle, the side 1 squared plus the side 2 squared is equal to hypotenuse squared. Okay, so as it applies to any of these triangles, side AB squared plus side AC squared is equal to side BC squared. Okay, so isosceles right triangles are what we're going to refer to as one of the two special right triangles, because it's going to make it a little easier for us when we go to implement the Pythagorean theorem. Let's go by means of an example and look at a few. Okay, so let's just say we start off with this triangle. We're going to say, okay, we know it's isosceles, which means we have two sets of sides equal, or two sides equal, I should say, not two sets. So we say, let's just say arbitrarily, this is 5 and this is 5. Now I want to find the hypotenuse, okay? So all I have to do is say, well, 5 squared plus 5 squared is going to equal the hypotenuse squared, which I don't know, so I'm going to call that x. So it's 25 plus 25 is equal to x squared, right? So which means 50 is what I get for x squared, right? Now, of course, we know that 50 is broken down as the square root of 25. Well, first off, we know that since x squared is 50, we know that x would have to be the square root of 50, which we'll say is the square root of 25 times the square root of 2, which is 50, which is 5 the root of 2. So it appears that when this side was 5 and 5, the hypotenuse is 5 the root of 2. Let's try another one. Let's just say this side is 8. I'm only giving you that one side. Well, even though I'm only giving you that one side, you automatically know this side, because this side is what? The same. So we're saying, well, that's 8 squared plus 8 squared. The hypotenuse we don't know is x. Okay, so then that's equal to x squared. So that means 64 plus 64 is equal to x squared. 64 and 64 is 128, okay, which is x squared, which means x is going to equal the square root of 128, which of course is 64 and 2. 64 and 2. So that's 8 root 2, which is what x is, okay? So here again we had the right triangle, which had both sides equal, making it hypotenuse. Both sides were 8 and 8. Here, the hypotenuse ended up being 8 the square root of 2. Let's try something. Let me just allege that this side here, AC, is 15. I bet you, well, I already know, we already know this is 15. But I bet you the hypotenuse is going to be 15 the root of 2. Okay, let's see. We don't say that. We're just going to make a hypothesis about that. So let's just see. So what we know, this time I'm just going to write it in the other order. I'm going to say the hypotenuse squared, x squared, is equal to, okay, 15 squared plus 15 squared. Again, we need to know 15 squared is 225. So it's 225 plus 225, which of course is 450. And of course we know then, where to get to? Okay, we know then that x is going to equal the square root of 450. And we know 450 came from 225 and 225, so certainly is 225 times 2. Times 2. So that's 225 times root 2, which is, okay, 15 root 2, just like we called it. So guess what? That makes life so easy, because if I have an isosceles right triangle, that is a 45, 45, 90 triangle, 45, 45, 90. And if I say this is 3, yeah, this is 3, and this is 3 to the root of 2. If I say this is 12, this side is 12, and the hypotenuse is 12 to the root of 2. That's simple. That's wonderful. I say, oh, this side is 87. This side is also 87. This side, the hypotenuse, 87 to the root of 2. Can't be any easier than that, right? Okay? Let's just make a little bet. Okay, let's say if I had 3 the square root of 5, then this side is also 3 the root of 5. Now, what's the other side going to be? Well, again, every time it seemed to be the leg times the root of 2. Well, let's see. What if I have to work this out now? Excuse me, I have to take a time out and turn this pen off so I can give you some more working room here. Okay? So let's come down here. I'm going to have to make some more room to work these problems out now. Okay? Put a few spaces in there. Okay, now here we're good to go. All right, so what we should suspect is, okay, that the hypotenuse is going to be the root of 2 times larger than the length of the leg. Okay, so let's just see about that. Okay, we're just going to see about that. I'm going to turn this pen back on. Let's do it in red this time. Okay, so we've got 3 the root of 5 squared plus itself, 3 the root of 5 squared. And we want to know what the hypotenuse is, which we're going to call x, right? So 3 to the root of 5 squared. Remember, the number out front, that's squared. So that becomes 9. The square root of 5 is squared, which becomes 5. Okay? So that's 9 times 5, which is 45. Well, it gives reason to suspect that this is going to be 45 too, because it's the same thing squared. That's 45. Okay? And so x squared is going to equal 90, but 90 needs to be broken down. X needs to be broken down as root of 9 times, okay, the root of 10, which becomes what? 3 the root of 10. But guess what? 3 the root of 10 is 3 the root of 5 times the root of 2, which is exactly what we thought it would be. Just take the side and multiply it by the square root of 2, and lo and behold, that gives you the hypotenuse. So this is, let's say this is 7 the root of 2. Well, then this side is also 7 the root of 2, and the hypotenuse, bring it down here, is 7 the root of 2 times the root of 2, which is 7 the root of 4. It don't make sense to have the square root of 4, so we just say it's 7 times 2, which is 14. So here's the hypotenuse standing in as 14. What if this is, okay, 11 the square root of what? 7, okay? Then this side is also 11 the square root of 7, and this side is going to be 11 the square root of 7 times the square root of 2, which is 11 the square root of 14. So all we're saying here with any of these 45, 45, 90s, whatever the length of the equal sides are, just call it x and x, then the hypotenuse is whatever that length is. I can't seem to write here very well. X the root of 2. X, x, and x the root of 2. 9, 9, and 9 the root of 2. Right? 72, 72, and 72, the root of 2. 28, 28, 28, the root of 2. 15 radical 3, 15 radical 3, you guessed it, 15 radical 6, right? 49, the square root of, what do you want, the square root of 10? 49, the square root of 10. This is going to be 49, the square root of 20. Of course, you don't want to leave radical 20 there, so you got to clean it up a little bit. So we'll just say it's 49, the square root of 4 times the square root of 5. Square root of 4, of course, becomes 2, so it becomes 98, the root of 5, right? Okay. The root of 7, the root of 7, the root of, you guessed it, 14, right? So in any 45, 45, 90, x, x, x times the root of 2. Give them the leg, multiply by the root of 2, and you got the hypotenuse. The next video, we'll go the other direction. We'll go from the hypotenuse to the leg. Okay? So there you go.